So A-class flares, these are the weakest solar flares with very little impact on Earth. B-class, these are stronger than A-class, but still relatively minor in terms of their effects. C-class, these are considered moderate solar flares. While they may not cause significant disruptions, they can still affect radio communications and navigation systems, especially at high latitudes. M-class, these are moderately strong solar flares that can cause radio blackouts, minor radiation storms. They have the potential to disrupt satellite communications and power grids. X-class, these are the most powerful solar flares with the potential to cause widespread disruptions to communication and power systems on Earth. They can also lead to significant radiation storms in space, pose a risk to astronauts and spacecrafts. So it's X-class flares that we want to look at and that what we pay attention more so as preppers to. X-class solar flares are the most powerful category of solar flare, capable of releasing enormous amounts of energy into space. When an X-class flare occurs in the sun, it can have several potential effects on Earth. First is radio blackouts. X-class flares can cause significant disruptions in radio communication. The intense burst of X-rays emitted during these flares can ionize the Earth's upper atmosphere, disrupting the transmission and reception of radio signals. This can affect a wide range of radio communications, including radio broadcasting, aviation, communication, and navigation systems. The next is geomagnetic storms. X-class flares are often associated with coronal mass ejections, which are massive eruptions of solar plasma and magnetic fields into space. When a CME impacts the Earth's magnetosphere, it can trigger geomagnetic storms. These storms can cause fluctuations in the Earth's magnetic field and induce electric currents in the Earth's crust. While most of these effects are harmless, they can disrupt power grids, pipelines, and communications cables, particularly in regions at high latitudes. Auroras is next, a pretty one. One of the more visually stunning effects of the X-class flares is the enhancement of auroras, also known as the northern and southern lights. When charged with particles from the CME interact with the Earth's magnetic field, they can cause the atmospheric gases to emit light, creating colourful displays of auroras near the Earth's poles. During particularly strong geomagnetic storms triggered by X-class flares, auroras can be visible at lower latitudes than usual. The next is satellite damage. X-class flares can pose a risk to satellites orbiting the Earth. The increased radiation levels during these events can damage satellite electronics and solar panels. Additionally, the charged particles from CMEs can disrupt satellite communication and navigation systems, leading to temporary outages or malfunctions. Now, the human health risks. While Earth's atmosphere provides significant protection against the harmful effects of solar flares, astronauts in space or passengers on high-altitude flights can be exposed to increased levels of radiation during an X-class flare events. Long-term exposure to high levels of radiation can pose risks to human health, including increased risk of cancer and damage to the central nervous system. Overall, while X-class solar flares can have significant impacts on technology and the infrastructure on Earth, the planet's robust atmosphere and magnetosphere provide a considerable degree of protection. However, these events are closely monitored by space weather forecasters to mitigate potential risks and minimize disruptions to human activities. So why do we monitor this? And is it ever going to happen? Is there ever going to be something that affects us so massively? Well, it already has done before, and I've mentioned it before on the channel, and I'm sure a lot of you already know about it, but I'm going to go through it anyway. And we're talking about the Carrington event, named after the British astronomer Richard Carrington, who observed it. It refers to one of the most powerful geomagnetic storms ever recorded, which occurred in 1859. It was caused by a massive solar flare, specifically a coronal mass ejection from the sun. Here's what happened during the Carrington event. So on September the 1st to 2nd, 1859, Richard Carrington observed significant solar flare. This flare was accompanied by a coronal mass ejection, a massive expulsion of solar plasma and magnetic fields into space. The coronal mass ejection reached Earth in about 17.6 hours, an exceptionally fast transit time. When it impacted Earth's magnetosphere, it triggered an intense geomagnetic storm. The geomagnetic storm caused the Carrington event to produce a spectacular auroras, or northern lights as it were, that were visible at unusually low latitudes. Reports indicated that auroras were observed as far south as the Caribbean and Hawaii. The auroras were described as being so bright that they woke people up in the middle of the night, and they were even mistaken for dawn. The Carrington event also had significant effects on the technology of the time. Telegraph systems, which were the primary means of long-distance communication at the time, experienced widespread disruption. The telegraph operators reported receiving electric shocks, the telegraph lines sparked and even caught on fire, and despite being disconnected from their power sources, telegraph systems continued to operate due to the induced electrical current in the lines. The impact on modern technology, if an event like the Carrington event were to happen today, it could have devastating effects on modern technology and infrastructure. The widespread reliance on electrical grids, satellite communications, and navigation systems means that a powerful geomagnetic storm could disrupt power supplies, damage satellites, and interfere with global communication networks. The Carrington event serves as a reminder of the potential impact of space weather events on Earth and the importance of it monitoring and preparing for such events in the future. It is often cited as an example of what could happen if similar events were to occur in the present day, highlighting the need for improved space weather forecasting and mitigation measures. The Carrington event was allegedly recorded at X25. We've had flares in 2003 that were in the X40s plus region. Luckily, that wasn't pointing at Earth, it was pointing away from us. But even though it wasn't directly facing us, it still caused a huge blackout in Canada at the time. So a direct hit from a flare of this size, there's untold consequences. We can take protective measures like Faraday cages and things like that. Till something like this on a scale of this measure happens, we don't know the true impact. The power systems in the UK have a structure in place that should prevent major damage from a mild solar flare, a large X-class flare that's not quite on a grand scale, but it's all untested and it's all theoretical. So it might just affect some systems, it might affect all systems, it might be to the point like you get an EMP that would cut everything off, even phones. We simply don't know. All we can do is prepare for the worst and hope for the best, which is what we try to do with all of our preps. And that's what the channel is all about. Thanks for watching this little video. It was just an explanation because so many people come into the live monitoring that we have at the moment, because I am monitoring the sun quite regular because we've had some really large sunspots and we are at the solar maximum or thereabouts. So people ask a lot of questions on there. So hopefully this does answer a few of the questions that keep coming up and it helps you in some way. Thanks for watching, guys. Don't forget to hit the like and subscribe, and I will see you all in the next video. Bye.